Welcome to Algebra 2B. This is Friday and we're working on day 2 of graphing rational functions. Right now you should have the note sheet in front of you, which has 1 through 3 on the front and 4 through 6 on the back. What I'd like you to do right now is please take out your notes from yesterday and open it to the second to last page and the last page. The reason being is because it has our definitions for vertical asymptote, horizontal asymptote, and a hole, and it shows us where those pieces of information come from. So I'm going to refer to that during these 3 problems that I'm going to walk you through. Okay? So take a second and take that out. Now let's look at number 1. We're given 2x minus 2 divided by 2x plus 2. So the first thing I'm always going to do is I'm going to factor that. Okay? And you can factor out a 2 here. Now I know you'd say, why don't we find the domain first? But the reason why I'm going to factor this out is so I can see what vertical asymptotes I'm going to have and what holes I'm going to have. Because remember, the difference between a vertical asymptote and a hole is that if it's factorable out, so let's say we could reduce the x plus 1 and an x plus 1, which we can't in this case. If we could, that would be considered a hole. But since nothing can be reduced, it's considered a vertical asymptote. Okay, so our vertical asymptote is at x equals negative 1, okay, because of our denominator, x plus 1. Our hole, nothing's factor reducible, so there's no hole. The domain, the only domain issue we have is that x cannot equal 1, so I'm going to write x cannot equal negative 1. And now the horizontal asymptote, okay. This is where I'm going to refer to the notes. It says in the notes, it says let r of x equal p over q be a rational function. Okay, so p is our numerator and q is our denominator. Now if you notice, they have the same degree. So there's 3 different dashes there. One if the degree of p is bigger than the degree of q, one if they're equal, and one if the degree of p is less than the degree of q. Okay. Notice how they're both degree of 1, so they're equal. So if the degree of p of q are equal, and a and b are the leading coefficients of p and q, respectively, then y equals a over b is the equation of the horizontal asymptote. So we have an equation here, and 2 over 2 are the coefficients. So that simplifies to 1. So our horizontal asymptote is y equals 1. Okay? So now the key here is let's graph that. So our vertical is at x equals negative 1. So I'm going to draw a vertical asymptote there. And we just found there's a horizontal at y equals 1. Okay. Now remember, an asymptote is a line that the graph will not cross. They may approach, but it will not cross. So what that means is we now have 4 quadrants here with upper left, upper right, bottom left, bottom right. And the table that you see there picks a point, an x value in each quadrant. So if I plug x of 0 in, I'm going to get negative 1. If I plug 1 in, it comes out to be 0. Negative 3, it comes out to be 2. And negative 2 comes out to be 3. So I'm going to plot those points in this graph. 0, negative 1 is right here. Okay, 1 comma 0 is right here. Negative 3, 2 is up here. And negative 2, 3 is right there. And what you'll notice is that's going to show us where our graphs are. Instead of the graph being in the upper right quadrant and the lower left, it's in the upper left and the lower right. So just by finding a few points, you'll see what the graph looks like. And notice how it fits just around the vertical and horizontal asymptote. Okay, so let's move on to number 3 down at the bottom. Same thing I did first in that last problem. I am going to factor it out. Okay, the numerator is not factorable, but the denominator is. So we have x squared plus 1 over x minus 1 times the quantity x plus 1. Okay, so if you notice again, nothing is reducible, so we do not have any holes. Okay, but now we have 2 vertical asymptotes at x equals 1 and x equals negative 1. So this is 2 different lines that are asymptotes here. Okay, now let's look at the degree. The degree is x squared for both of them, 2 over 2, so it's the same idea. If the degree of p equals the degree of q, and a and b are the leading coefficients, then y equals a over b. So it's 1 over 1 again. So our horizontal asymptote is y equals 1. And now let's finish up with the domain. That comes from our vertical asymptotes and our holes. So the only values that x cannot equal is -1 and +1. Okay, so let's graph those vertical and horizontal asymptotes. We have one at -1, so this is going to be a pretty tight graph. We have one at +1. And we have a horizontal at y equals 1. And now we just need to plot a few points. Okay, so if you plug -2 in, you will get 5/3. If you plug +2 in, you will get 5/3. And if you plug 0 in, you will get -1. Now on the last problem, we plugged 2 points in each area just to make sure that's where our graph was. But now what you'll notice is that if I plot these 3 points, -2 5/3 is somewhere right here. +2 5/3 is somewhere right here. And 0 -1 is somewhere right here. You can figure out where all 3 graphs are, and they're going to fit in the quadrants. Well, in this case, there's 6 open areas between the asymptotes. So we have one going right there. We have one small one right in between these vertical asymptotes. And then our last one is right here. Okay, so that's our graph there. So all you really need is 1 point to figure out what the graph looks like. Okay. So now let's flip over number 4. Number 4, I'm going to start the same way I did last time. I'm going to factor. Luckily, it's already factored for us. So I'm going to write down the reduced version. Y equals 1 over x minus 5. Now please don't fall into that category of thinking if 2x divided by 2x simplifies to 0, that means it's 0 over x minus 5. So the whole thing is 0. Okay? Remember that simplifies to 1. So the key here, this is a little different from all the other problems we've done, is we found our first whole. Okay, something factored out. There's a common factor in the numerator denominator, 2x over 2x. So that's our first whole. Okay? So we know that this whole has an x value of 0. And the way we find the y value is you plug it in for x. So if you plug that in for x, you have 1 over 0 minus 5, which gives us -1/5. So that is where our whole is. At 0, comma -1/5. So our whole is going to be somewhere on that graph. We'll wait a second to plot that. So now let's go to that vertical asymptote. We know that there's a vertical asymptote at x equals 5, based off that denominator. Okay. Now let's look at the horizontal. This is the first case where we now have the denominator has a greater degree than the numerator. So remember, we're dealing with p over q. So the horizontal asymptote, my note says, if the degree of p is less than the degree of q, then y equals 0 is the equation of the horizontal asymptote. Okay, so if that denominator has a bigger degree, then y equals 0 is the equation. So our horizontal is y equals 0. And remember, the domain is based off the holes in the vertical asymptotes. So we know that x cannot equal 0 and x cannot equal 5. So now let's plot our graphs here for our asymptotes. X equals 5 is the first one. It's a vertical line at x equals 5. And we have a horizontal at y equals 0. Okay, now let's plot a few points. If you plug 4 in, you get -1. If you plug 6 in, you get +1. So this is showing us where our graphs are going to be. 4 -1's right here, and 6 +1 is right there. Okay, so I'm going to draw up my graphs. But before I do the other side there, we got to remember we have a hole at 0, -1/5. So there's going to be a hole right there. So draw up to that hole and then go through. Okay, because remember we factored out and we reduced the 2x over 2x. Okay, so what I'd like you to work on now is please go down to number 5 and skip number 5. Okay, so now please do numbers 2 and 6 and talk to the substitute teacher to give you the answer key there so you can make sure you got 2 and 6 correct. And then please get the homework. Okay, the homework is just practice a few more graphs. Coming on Monday and answer a few questions. Thanks guys, have a great weekend.